O Espaço Aberto Ciência e Tecnologia de hoje é especial. Começamos em uma das instalações da IBM, aqui nos Estados Unidos, que reproduz o cenário de um dos shows mais vistos da TV americana. O Jeopardy, que começou nos anos 60, é um programa de perguntas e respostas um pouco diferente, porque os competidores recebem as respostas e têm que formular rapidamente as perguntas corretas.
This is Jeopardy, the IBM Challenge.
Há alguns dias, se a resposta apresentada fosse: é o computador que venceu seres humanos no jogo de questões mais complexo que existe, a pergunta correta seria: o que é o Watson?
Hello, my name is Watson.
Watson?
What is Soren?
Soren is right, and that puts you into a tie for the lead with Brad.
No programa de hoje vamos mostrar esse supercomputador, o Watson, e entender o trabalho da equipe que criou um processo de raciocínio que não usa neurônios, mas semicondutores. O Watson vai um pouco além da dimensão de uma máquina e se torna um novo competidor no jogo da vida.
Watson?
Who is Bozo?
Nice! Good job, Watson.
O Espaço Aberto Ciência e Tecnologia Especial está só começando.
Human language is very vague and ambiguous, and it's ultimately grounded in our experiences and in the world that we live in. We understand when each other talk most of the time because we understand what a race is or what a tree is or what a building is because we live in the world and we experience those things. And computers don't. So all they have are the words. All they have is the information. So the best we can do for a computer to understand human language is to try to give it the connections between words that can help it make sense of things.
Comprehension of the question. Analysis of whether you know the answer. Strategy of do I bet or do I not bet? It's a bunch. And a very, very short time frame. Yeah. So when you guys started from ground zero, how did you solve all these problems? For instance,
well, when we agreed it was a very nicely formulated challenge. That's obviously not why they invented the game show, but it turned out to be a very nicely formulated challenge for a machine. But when we first started, we thought it was way too hard and we weren't going to be able to do it. But we decided to at least spend a year looking more deeply and in a more rigorous way at the problem, analyze it, come up with some initial ideas, and change the way we'd been doing research for the past 6 years to focus less on very small incremental results, which is how the scientific community generally works, and focus on a major result. Can we get significant improvement in the way we understand and answer questions within a year?
We mapped 4 different colors to 4 different levels of confidence. So green would indicate that Watson has a very high confidence level for this particular category, that he probably knows the answer.
Watson.
What is finger?
No, that is wrong.
But he's ringing in green because he had high confidence. He should have gotten that right. He's saying, I knew this!
How does Watson think?
So Watson does not think the way a person does. Watson is a machine, and one of our first most important advances was to throw away ideas about making the computer work and understand language the same way people do. Watson often does not understand a question completely, but it breaks the question into a lot of different parts and analyzes answers with respect to different properties of a question. So it'll look at what type of thing is being asked for. What are some other words that are highly associated with these words based on just counting word frequencies in large, like the web.
Can you give me an example?
So how do you know who Ayrton Senna is? Am I pronouncing that? How do you? Ayrton Senna. So how do you know who he is? So you would have, over a lot of data, over a lot of passages and sentences, you will find a big correlation just by counting that a lot of times when Senna is mentioned, Formula One is mentioned, or auto racing is mentioned. So you learn from that there's a strong association between this word. Watson has no idea what it really means, but that name and these other words are associated. So, there must be some association between that and racing, and that and Formula One, and that and cars, you know, and going fast, and other words that it finds are mentioned more frequently.
All of this happening within 3 seconds.
Within 3 seconds. So what happens in the computer is that each answer Watson typically considers a couple hundred answers for each question. For each answer that it considers, it sends that answer to its own processor, to its own CPU, and there's thousands of them in Watson. And each processor is then just looking at this one answer and trying to gather evidence for that answer. So per answer, the computation takes 1 to 2 seconds, but each answer gets processed on its own computer in a sense. And then that takes about 2 seconds, and then all the answers come together again, and then all the evidence for each one is compared to the others, and we rank them to see which answer has the most evidence, and that answer becomes the top-ranked answer. And then we do processing to understand, when I have this much evidence for an answer, what's my confidence?
Watson's behind you. Watson will be the equivalent of how many computers that we have at home?
Watson is the equivalent of about 6,000 home computers. So Watson runs on a regular computer, just a lot of them, so that we can consider a lot of answers at the same time.
But not in the traditional sense of parallel processing, is it?
It is. It's called embarrassingly parallel. The computation that Watson does is embarrassingly parallel. It's actually...
That's the way it's called?
That's a technical term, embarrassingly parallel. It's so obvious that this can be done in parallel, because we take the work that Watson does for each answer is exactly the same for each answer. So we just take each answer, send it to its own processor, and then, you know, Watson's doing the same thing in parallel. If you could imagine, if you could think that, if a human could think that way, you'd be partitioning your brain up into pieces and having each piece try to figure out which is the answer. Of course, that's not how people do it at all, but that's how Watson does it. And the fact that Watson is doing things so much differently from how people do it really shows, not when it gets the answers right, but when it gets the answers wrong. So the mistakes Watson makes are almost always not mistakes that people would make. And that's because it's of the way it thinks.
The worst thing is if Watson just crashes in the middle of the game. That's what you don't want. But then the second worst thing is if you have some horrible bug where Watson starts getting everything wrong.
What are trousers?
No.
What is harness racing?
No.
What is taxi to the dark side?
No.
What is artificial sweetener?
Come on now. No.
What is milk?
No. Very nicely done.
We both beat them.
Good for you.
Humans.
In the process of development of Watson, were the mistakes the big driver of development?
Yeah, so we spent a lot of time from an engineering perspective looking at the errors that we had and analyzing why Watson got questions wrong and trying to develop approaches that in the future you're never going to get that one question again. So in the future, it would learn from the mistake. We, the developers, learn from that mistake and try to figure out more general solutions that would get that question right, but also get a bunch of other questions right as well.
14 years ago, IBM came out with Deep Blue, won a chess match with Garry Kasparov. But then there was no much use for a machine that can play chess. When you designed Watson, did you design already thinking of the usefulness of a machine like this?
We knew at the very start that the capability for having a machine that could understand natural language had business value. Every professional today has to deal with the problem of too much information, not enough time to deal with it all. So a lot of people are out there trying to do their jobs and aren't aware that there's some new piece of information that they might have used today if they had known about it. And almost all of that information is available in a natural language of some kind, not in the kinds of data that computers typically deal with and understand, but in English or in Portuguese or whatever your language is. People are writing, people are publishing scientific results, people are publishing lab studies, if you're talking about medicine, in the financial world, in the legal world. I mean, there's information. The vast majority of information is in human language, and we knew to begin with, and this is why it was our research agenda, that there's tremendous business value in trying to be in successfully processing that information.